Okay. Then there's no telling where my big fat head is because I can't see where it's at when I'm. But one of my videos, my big fat head was covering up the notes, so it's fine. All right. So I was talking about how I made this up a little bit off of the beaten path from the other teachers because I just felt like this would make sense doing this. So that's what we're doing. Stole this off the internet, what amplitude is. Just pay attention to this real quick. And then I guess I could use my pen to explain this a little bit. Amplitude in physics. How many people took physics? Raise your hand. You may or may not have had some amplitude-ish kind of scenario in physics where the maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium position. So it is equal to 1/2 the length of the vibration path. Here's a couple examples of this. One we already had at the beginning of the year. I was like, oh my gosh, with the first video I showed you from AP, it was the person on a Ferris wheel and how high they were above the ground. How many people recall that video a little bit? And then they had this curve here. And then as you traveled along this, the graph was doing this, your position over time. And I said, oh my gosh, that's an upside down cosine curve. We'll get that later. All right. But the point of equilibrium in that one is the middle of the Ferris wheel. Maybe not the greatest example for that. Another one would be a pendulum. So here's the point of equilibrium for a pendulum. Then I pull it this way. This is on one side of the point of equilibrium. Then it swings to the other side, and then to this side, and then that side. Another one is a spring. This doesn't really work for this, but say this is the spring in resting position. Pull it below. This one's great for the sine curve. Below means below the or x-axis. Below, and then you let go, and it goes doing, 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 up and down from a point of equilibrium. All right, so the point of equilibrium makes a lot of sense in that one, and that's what I want you to think about when I talk about the sine curve and its amplitude. Period is just after one cycle. So we already know that. One cycle is created. Am I in your way? Or am I good? Am I okay? Okay. I just wanted to make sure I could see that. Yeah, why don't you do that? You'll be able to pay attention a lot more today, won't you? Shh, let's not say why. Okay, all right. Sorry. All right, so for sine, what was the high point for sine yesterday? What was the high point? 1. What was the low point? So here's the thing. That's a distance of 2 units. It goes 1 above and 1 below. But the amplitude is 1. 1 above, 1 below. Now I understand why it was always half the y-axis distance covered. I understand it a little bit better now. It's the, 1 above and 1 below the point of equilibrium in a real world question. Believe me, they're going to get real world in this AP. You know that. They try to, I guess that's good. Right? And then the period was what yesterday? When did this end? Come on. When did this end? 2 pi. So we're going to do this fractionally, man. We're going to have to fill out these values, but you probably remember them yesterday. But let's do this fractionally. This one right there is half of that period. What's half of 2 pi, everybody? Pi? Hey, what's half of pi? It's always scared. Everyone's like, fractions. It's pi over 2, man. Right? And we had that yesterday. Oh, so let me reiterate. We're not going to do 17 points to graph one sine curve. That was just an extrapolation to see the pattern. We're only going to find 5. We're going to find all the zeros, high, and low points, and then that gives me a sine curve. All right, and then by the way, I'm going to do this all day long. We probably already know what this is, but I'm going to put this fractionally. I lost that pi there. This is half of the period. Wrong, wrong, wrong. This is 1/4 of the period. This is half of the period. And then this is 3/4. So for us to survive in the future, maybe we could do that, to find these x-axis values. So what's 3/4 of 2 pi? It was 3 pi over 2. This is what I'm going to do, though. These are all a distance of pi over 2. So I always do this. And this is for the non-fractionally challenged. How many of those do we have? I don't know. 1 pi over 2, then 2 pi over 2. 2 pi over 2 equals that. What's next? 3 pi over 2. Hey, is this 4 pi over 2? If you're not fractionally challenged, that's how I'm going to find that third value all the time. I'm just going to do iterations of 1/4 of the period until I get to that third one. This is for the non-fractionally challenged. All right? I do yell at them. I'm not the most popular teacher. I know that. I know. Um, I couldn't. Anyone? Care less. All right. Because I know what kills people in pre-calc, and it's not the pre-calc. It's grade school fraction work. I've told them that all year long, and I've tried to teach it. I've actually tried every time I possibly could to teach fractions because I know what it comes to when we get to this section. Hey, how does sine start? Does it start at 0, high point, or low point? What's the answer to that? I asked this yesterday. What's f of 0? What is he doing? That's just function notation. Input, say it. So when I input 0, what do I get? 1, 0, or -1? What's the answer? 0. You should remember sine starts at 0. And then what happens at pi over 2? What's f of pi over 2? Where does it go? 0, 1, or -1? What happened next? You could look at your picture from yesterday, but you shouldn't have to. It was the 1. No, it's not a half. That was pi over 6. Right? We're skipping those. We're going to the key components, high, middle, low. What do you think is going to happen at pi then? So, by the way, the answer to that was 1. This one was 0. I like asking those in the midst of a graph so you understand what function notation is. That last really difficult, I agree, very difficult question that they went in the notes yesterday. It was just a GEOF question. It was just what do you expect for outputs? The wording of the question is always, complicated. It's really complicated if you don't know, these notational things. All right, and then I just fill it out. It goes back to 0, then -1, and then back up. So the way you need to think about sine is it's 2 bowls. And that's why I put that over in the comments over there. 2 bowls. Now I'm a little nervous because I'm putting this on YouTube. I'm wondering if this video is going to be canceled by YouTube. I'll show you why in a minute. It's like I made videos of all my girls, their first year in life, but I put all this music in it. So if I put it on YouTube, you know what would happen? Because all the music, the copyright BS, which I feel like I'm not making money. It's not like doing anything. And anything, wouldn't it be an advertisement that we picked your song, that we like it, and then someone might download it? Whatever. YouTube. Okay. There it is. Here's where I could get sued. Okay. This is why I always call how many people saw the Karate Kid? I asked you this. All right. The good one, the old one. Yeah. The new one I'm not even talking about. Yeah, I'm not talking about that new one ever. All right, so the cosine kid, this is what I think of cosine. All right, because how does cosine start? It starts at its high point, right? So I'm jumping ahead of myself, but I just want to explain how I'm going to get copyright issues on YouTube. All right, for talking about the cosine kid. We'll finish that off in a minute, but it is 1, and the period is 2 pi for this, but it starts different. And these are all identical to the previous one. Pi over 2, 3 pi over 2. And then all this is reflections. Did I fill out the ones on the left? I did. Okay, I think I was jibber jabbering and talking while I was doing the same thing. Okay, and then cosine starts at its high, goes down to 0, goes down to -1, and goes back to 0, and then back up to 1. Here's the cosine kid. Hiya. Sometimes you do run over. Now look at. Do you see this? Look at that. Okay, anyone that goes through like this and throws that graph up like that, I'm going to get you with the red pen of vengeance. Because what is that telling me? You're saying that the highest value is bigger than what? Say that number. 1. That's an illegal graph right there. I get people all the time with a little half point on a graphing quiz. Maybe not on every single one. I ding them once and say, stop it. All right. So again, the cosine kid, the karate kid, he does put his hands like this. That's why I like it a lot too, because turn, all right, and then go back down. All right. Anyway, I made my point there. If you don't want to do it, you'll just you'll suffer the consequences. All right. So that's life. That's life. Life. Certain things end up, certain things happen to you. All right. So anyway, I kind of interrupted that. You'll see that your X values kind of get in the way. On when I had graph 2 cycles, I kind of don't fill out that second part. Rah! Someone just sucked all the oxygen out of the room over in that area over there. Okay, now here's what we're gonna change. It was you. No. All right. Here's what we're gonna change. And all this is not a big deal. Hey, what's I know it's gonna be tough. What sine of pi over 2? Look at your picture. What sine of pi over 2? What's the output value? You can look at the graph. 1. But then what if I put a 4 in front of that? What sine of pi over 2? 1 times 4. 4. It's just a stretch. So what amplitude is a vertical stretch or shrink. Okay, and that's all it is. Vertical. We're gonna be really the other first hour. I wrote all the words out. I'm done. I'm on strike. I had to break up a fight today. I'm upset. See humans at their worst is just demoralizing. It really is. Sorry. Anyway, wonder if I'll remember this in the future. Yeah, I'm leaving it in. You should put absolute values around the B. Hey, what do you think the B does then? If the A is a vertical stretch and shrink, anyone? Horizontal stretch or shrink. Okay, and it is true. And I know I'm coming out of left field on this one maybe a little bit, and I won't have time to prove it, input, say it. I used to input, output, and prove points that the B value does what it does. Can you just accept it? All right, and just move on? I hope so. All right, so here's the difference. Here's now the difference, and I am going to reference some differences with our new questions compared to the parent, and then some of the other ones comparatively, how they change. Now the period, that's where the graph ends, whatever 2 pi over b is as an evaluation. All right, but here's what sine looks like. When these change, it doesn't matter. Either stretches or shrinks. It doesn't change this. Starts at 0, goes to the high point, back to 0, low point, back to 0. That's what you need to know about sine. This is why I wanted to do this today. I wanted you to solidify the basic characteristics of sine and the basic characteristics of cosine, and then change some amplitudes and periods. It's really a good progression. I'm not saying they didn't do that. They just have a weird way of getting around stuff, and I'm getting sick of their progression sometimes. I want to do something that seems normal to me. All right, and then amplitude again is A, but for the cosine kid, it starts high, then 0, then low, then 0, then high. Whatever these numbers are, we're just going to mark them. Be careful on cosine about that big thing I made. I think every teacher should be mean about that. Every teacher should be mean about that. There are certain things. I'm not the biggest stickler. I don't think you should think that. There are some things that get on my nerves. That's something different that other teachers maybe don't care about, but whatever. All right, so all these words here, finding amplitude and period and radians, I feel like to read it when I'm doing a video. Sketch 2 cycles. Here's what I had some clown do last year. Oh, you want 2 cycles on a test? Here you go. Here you go. Here's cycle number 1. There's a cycle, and then there's a cycle. Give me all the points, Mr. Samuelis. You get it? That's a bicycle. Never mind. Nothing. I get nothing. Here, I got to pull this out. Wait, let me tell that joke again. Then there's Mo. Mo can't put his phone away, so probably looking at the fight video. Those people should be. That's what I need. I needed that like right away when I did that joke. Crickets. Anyway. Okay, so what's the amplitude? What's the stretch vertically? What's the stretch vertically? 3. But you know what it means? So the amplitude is 3. And I should have put absolute value of 3 is 3. You'll see. Example, 4th one, or it's numbered 8. You'll see something different there. All right, so that means this is all we do. Just put 3 and -3 there. Just humor me. But do listen. And I'm probably going to write this. This is a cosine graph. Comparative to the parent function, now this sucker is way up here, 3, and way down here, -3. And it would go that high. It'd start way up here. So comparative to the parent, I want you to think about it. Can you do that? You know what I'm saying? So I go 3 high to -3. So it's a way bigger wave. This just came into my head here. Anyone ever listen to the radio? Radio? You know what AM stands for? Amplitude modulation. That means it's a longer wave. It carries out longer. That's why you can listen to an AM station much longer in a car than FM. You know what FM is? Frequency modulation. That's a shorter wave. It's more crisp, but it doesn't last as long. That's why you lose an FM station. Did you guys know that? Right, that just came into my head there. Frequency is a word that deals with changing the period. So amplitude modulation is a longer wave. That's why it carries out longer. That's why an AM station lasts longer in your car when you're traveling far away. Huh? See? Getting some stuff here. All right. And then what's 2 pi over 2? I didn't know I changed degree. 2 pi over 2. Nobody got that in the other, that little AM FM thing. That's pi, right? Right? Oh, so then here's another thing. Here's how this green graph would look different to this one. I'm going to write it, but then stop it. It would end at pi. So this graph would look like this. It'd start 3 high instead of 1, and it would complete a cosine curve at pi. See how that's really, it's a bigger wave, but it's actually not as long, so it's kind of got a couple things going on that. All right. But anyway, so let's go back to this. All right, so pi. So this is what we have to do. This is all we got to do. We just put pi here. We're not going to get crazy with it. We're not going to compare them anymore. I do want you to think about it, though, how it is different. Uh-oh, the yawner. What's up? Remember when you were yawning? 2 pi is the standard, and then the b value changes the period. So it's 2 pi over whatever the number is there. Sorry, picking on the yawner. All right, so 2 pi over b, 2 pi over 2. Okay, so why 2 pi? Because the parent's function period is 2 pi. So all the baby functions are based off of the parent. All right, now here's what we got to do. What's half of 2? What's half of pi? Which goes right here. What's half of pi? Pi over 2. It just makes me cry how many students make this difficult. And I'll give you an easy way for the next one. What's half of pi over 2? Just multiply the dang denominator by 2. What's half of pi over 2? It's so easy. Okay, now listen. 1 pi over 4. 2 pi over 4. What's next? Is the last one 4 pi over 4? Does that equal 4 pi over 4? Yes. These are simple grade school questions. Ugh. That's why I get anxiety when I do this and how many students cannot deal with the fraction. And you're sitting here as seniors and juniors. This can't happen. All right, but anyway, I can only lament. What's cosine? Where do I start? High point. I used to ask this like if I force people to answer questions. All right, Mo, what is, because Mo and his phone and everything. Where does cosine start? High, middle, or low? High points. Just happens to be 3 now instead of 1. He's right. What's the next one? Hey, Mo, what's f of pi over 4? That's just asking pi over 4 comma. Get that earbud out. Oh, my gosh. You stuck that thing back in. These students. This is unbelievable. Why do I care when they don't? Ah! I should take that earbud and go like this. Go, but then you call your lawyer. All right, anyway. What's the answer? 0. It's unbelievable. How's that drink? Is that good? Now we got drinks. We got earbuds. It's like a coffee shop in here. We're all lounging around on our phones. Who cares? Who cares? Teaching? Where are we teaching, everyone? In America. Fighting out in the halls. Just great stuff. Remember I told you I was going to be a little bit lazy here because these get in the way a little bit, but in a test, you're going to fill out those other ones. It's a cut and paste. It isn't even anything. It's not a big deal. All right, let's move on. Let's become professional for the first time in forever. Right? 2 is the amplitude. Okay, so that's not as high as the last one, but it is higher than the parent. So it is 2 to -2 instead of 1 to -1. And the period is, what's 2 pi over 4? 2 pi over 4. What's 2 pi over 4? Pi over 2. Heard something weird out there. 2 goes into 4 twice, 2 on the bottom. Okay, and this is all you got to do. Pi over 2. What's half of pi over 2? Multiply the dang denominator by 2. What do we get? Pi over what? And then what's half of pi over 4? Multiply the denominator by 2 again. Okay, and then play the game. Or if you don't like it, this is 1/4 of the period. Do all that math off to the side. This is 1/2. This is 3/4. It's really what it is. I'm cutting into quarters. That's why I could do this. 1 pi over 8, 2 pi over 8. What's the third one? No. What's the third one? 1 pi over 8, 2 pi over 8, 3 pi over 8. Is this 4 pi over 8? I always do that to make sure I'm okay. Is that 4 pi over 8? I don't know. I'll learn that in calculus. Wrong! 4 pi over 8 does reduce to pi over 2. I do this too long. This is the stuff that gets the students, man. Uh-oh. Am I in trouble? Is it for me? Hopefully I'm done. Oh, Callie. You get to go. Wait. Yeah, I guess you're going now. No, appointment time 5th. You're on the video. I just named you. All right. And then here's negative pi over 2. So I guess that's during 5th hour, right? Is that what that means? All right, now where's sign start? 0, high, or low? What's the answer to that, everybody? 0, then high. You get it. Let's speed this up. Low, and then back to 0. Bowl. See, sometimes it kind of runs through these. That's why I'm kind of not writing these over here. Just cut and paste these over here, but I don't want to run into the X values. All right? I know that's kind of being a bad teacher. I knew it. I say it every day. And then for sine, you don't have to worry about those arrows. They do continue up or down. So I asked Mo yesterday, or was it yesterday, Mo? What day were we doing that AP thing? And you got a 0. I go, are you even trying? You know what his answer was? No. Just like, how dare you ask me? Teaching in America. Right, Mo? Mo knows. Aw. This one's going to be such a cute little cosine curve. You just want to squeeze its cheeks because it only goes from 1/2 to negative 1/2. And then look at what happens to the period. 2 pi over 3, and there's nothing to do about that. That's it. So I'll tell you how this is compared to the parents. It would be so cute that it would look like this is a cosine curve, right? So I'd have to go, no, that's not that. That's this one. It would be only half from here to here, and it would end 1/3 of the way here. So it'd be like this. Oh, look at that cute little thing. You see it? That's what it would be compared. Don't you just want to, okay? All right. Comparative to our next one, oh my gosh. You wouldn't believe how cute it is compared to the next one. All right. But let's get this one. It doesn't matter. You're just going to do this. You're just going to do this. You're going to mark it. You're going to mark it. You're going to mark this. And then you're going to do your frac. Now the stuff hits the fan. I actually put this in first period. I still couldn't get anyone to answer this. That's why I want to cry. What is half of 2 pi over 3? What's half of 2 pi over 3? What's the answer to that? 2 pi over 6. I get a pi over 4. Okay, hold on. Okay. But what's 2 pi over 6 reduced to? Well, this is what we should have done in the first place. We should have canceled the 2. So what is it? Pi over 3. I can cancel in my head. And now we're easy. What's half of pi over 3? You just multiply the denominator by 2. Yeah. And then 1 pi over 6. Okay, careful. 1 pi over 6, 2 pi over 6, right? 2 pi over 6. What's next? 3 pi over 6, but you better not write that. What's 3 pi over 6 become? Pi over 2. So you gotta lament with me of all the students in the past, and please don't be that student. How walking out of here saying, oh my gosh, graphing, sine, and cosine's mind-blowing. It's just fraction work. That's all it is. How's cosine start? High, low, or middle? High, middle, low. See how easy it is? You just gotta, this is why I love doing this now. I don't want to be stuck with the AP stuff. Actually, AP even said you could do your normal curriculum and they should be fine for the AP exam. I want to be normal. I want to do what we were doing last year. This is a normal progression. whatever. I'll suffer the consequences if someone turns me into the Gestapo for doing something different. Oh, I can't wait to see. Why don't you ask what Cameron did today? All right. Anyway. All right. So -4, absolute value 4. Hey, but what does that negative do? What does that negative do? We should know this from other stuff. What does a negative do to a graph? It what? But I want to make a point. We could be jerks. We will be. I mean, I'm going to be honest. We might have a multiple choice question on this and say, what's the amplitude? And we'll list -4 as one of the questions or answers. -4 or 4. Which one is it? 4, because it's a distance. It's a displacement from the middle. What time is it? I saw you look at the clock. What time do we get out of here? I had 7 different answers on that. Someone said it's 42. When do we get out of here? 43. Thanks for your help, everyone. Teaching in America. All right. Now, notice what I did. Pi over 3. That's 1/3 pi. So I want you to do it. All kidding aside, I want you to know that that's that. We do mess around. I know I get on them. So some people understand my stuff and some don't. I know. I think I kind of know this. Some people do kind of. I feel like kind of really like me. Some people really hate me. I just know it. And guess what? I couldn't care less. I'm going to be me. I know a lot of things I'm trying to teach you are helpful. And some of you will begrudgingly say in college, you know what? That jerk was right. Then you'll be mad about it. All right. What's half of 6 pi? What's half of 3 pi? It's just 3 pi over 2. You don't blow a brain gasket on that. You stick a 2 in the denominator. Now it gets, you want to get nuts? This is the one that can be tough. 3 pi over 2, 6 pi over 2. Remember, these are all 3 pi over 2 chunks. So 3 pi, 6 pi over 2. What's next? 3 pi over 2, 6 pi over 2. Add another 3 pi over 2. You get 9 pi over 2. This is just adding fractions with a common denominator. This is why this gives me anxiety when students struggle on this. I do get anxiety for this. All right. All right. Now, done with that. Remember, I'm being lazy about this. Sorry. I just don't want those X values to be in the way. I should have spread these out a little bit more. I should have had a bigger coordinate plane for you. But now that I think about it. Okay, so how does sine start? Well, sine starts at 0, so we're fine there. My next one, though, is important. So we start at 0, and then what's 3 pi over 2, high or low? Which one is it now? It's low because we had that flip. That's the only big deal on this one. We already know that. Okay, so it's the low point. All right, I do kind of have to speed up. I'm messing around with you a little bit too much. I'm just kidding around with the other CAT teachers. I just want some normalcy. I want to do some of the things that we did last year because I think they're still valid. And then we're going to come back to the AP thing, and then I think the vocab that they use in the next video will be a little bit better for you. That is my philosophy. I'm allowed to have those thoughts. That's all I'm saying. Okay, I'm not going to do 10 because 10 actually I did. You can see this. This is my drawing, right? Right. I stuck that drawing in there. We're just not going to get to it. This is a note. I'm just not going to make it. Your homework starts after this, and it's very repetitive. All right. But I wanted to piggyback off of yesterday's AP video or flip math or whatever. What the AP is assigning is important because I do kind of like it. But now I have a changed graph, and I thought, hey, let's give you an equation, but then graph it for you, and then ask these questions, okay? So it's all done for you, but it's not quite. So this is just what is the minimum. What's the lowest point you see for y here? Very simple. What's the lowest point? -4, okay? What's the highest point that you see? 4. Now, the difference is location means x's. So what are the x's that create these values? That's what we need. And then I like this one. I left this one on purpose because I wanted you to do a little bit of work. I wanted you to understand, okay, from the lesson, this should be a period of 2 pi over 2 because b is 2 here. Oh, I couldn't quite see this, but now I do. That's pi. See it, right? Got it? So you just do a little thing. Oh, and then they gave you this one. And then I like this program. I use CUDA. They just gave you a couple, but they don't give you them all. Because then this is the maximum, and this is where it's located. All right, everybody, can you tell me what that x value is? We've already done this math. So pi over 2 is here. What's that? Pi over 4. We're there. Okay, so we just had to do a little bit of extra work there, but remember what I did. All. So we're going to include that thing that I did yesterday. All right, and I don't think the other math teachers did yet. They will have to, so I'm okay with doing this a little ahead of time. How far away are these? Don't blow a brain gasket. What general word describes how far these are? It starts with a P. Period. And what was the period? Pi. So it's pi n. And then let's impress everybody. Let's put that NEZ. But what does that mean? N is an integer. So if I plug in 0 for n, I'm here. If I plug in 1 for n, I'm here. If I plug in -1, I'm here. It gives me all the locations of the high points. Right? So that should be understood. Now the low points. You know what? You don't have any rules on this. I could pick this one. Why would I pick this one? Symmetry. If that is this, then what is this? Net. Say it. Negative pi over 4. And then how far away are these? You didn't answer. Go ahead and say that thing. They're pi, the period. Right? And then the zeros are a little bit different. The zeros are a little bit easier. I'll do those in blue. Here's a 0. Where's that located? Say that Z word. 0. And then what? Pi over what? Okay, so you know how you do that? You actually just say pi over 2n, because you know what? N is an element of integers. When I plug in 0, I do get 0. When I plug in 1, I do get pi over 2. I plug in -1, I get that negative pi over 2. Those are all spot on. Okay, this is why I did that. Now, I was in first hour, and I noticed these next questions were a little bit annoying. So, and I just made them up myself. So I think one interval is enough for all of these, because there's 3 and it gets a little bit crazy. Just give me one, and then I could envision this being like a multiple choice question. All right. With the here would be easy because I have all these values marked, and then all you have to do is cut and paste these. It'd be a little bit easier, but it's still kind of annoying. So one interval of increase. I think this would be the smartest one to choose because we already found these values. First of all, isn't that increasing from there to there, right? What were those 2 values that we found, the green and the red? What were those? Come on. Negative pi what? Over 4, 2 pi over 4. And I think that's good enough. First hour, we were writing all 3 of them, and it's just like, we don't have time. All right? And then interval of decrease, we can go right after that. So that was already negative or positive pi over 4. What do you think this one is? What do you think this one is right here? What do you think that one is? It's going by over 4. Is 1 pi over 4, 2 pi over 4, 3 pi over 4. So this is why I like this. It's working with those fractions. That's why I like the CUDA not filling out all those values. You have to do just a little bit of fractional work. Then the next ones are going to be easy. I'm just randomly picking some like this. What is that? Concave up or concave down? Well, then I could see those. That's negative pi to negative pi over 2. That one's easy. And then concave up, I got another easy one. We'll do this in pink just in time for this made-up holiday today. What? All right, and then that's from negative pi over 2 to 0. Just randomly grabbing one of the intervals that demonstrate the situation. So, I don't know. That was just something I came up with after yesterday. I'm like, hey, I want a graph with changing the period. Hey, but then I want to incorporate those questions they had yesterday because I liked them. So that's my plan. Sorry for all the other stuff. I am what I am, and that's all that I am. Anyone know who that is? Starts with a P. I'm Blank the Sailor Man. Popeye. I am what I am, and that's all that I am. I never know how to stop this video.